In this video, we are going to discuss about the derivations of the first equations, which is here we will discuss about uh, that in the previous graph we can say that this is basically the previous graph. We consider that an object is moving with initial velocity u, and after time t its final velocity become v, as shown in the graph. Here we will take velocity along y-axis and time along x-axis because v is time dependent quantity. So our object moves with initial velocity u and cover a distance from here to here, and when it reach on this point its velocity become v, which is final velocity of the object. So according to this graph we can calculate its gradient. Gradient is rise over run. So in this case rise is the velocity, so change in velocity, and run is change in time. So the gradient of velocity time graph, in velocity time graph the gradient is always equal to the acceleration of the object. So we can say that in the graph gradient is equal to the accelerations. According to gradient definitions, according to the graph will be a del v over del t, change in velocity or change in time, which is equal to the acceleration. Mean the rate of change of velocity is called acceleration. So this is equation 1 and this is equations 2. Just we compare equation 1 with equations 2. So we can write a is equals to del v over del t or del v over t. So we can write, we also know that del v is v minus u, mean initial final velocity minus initial velocity, so del v. So we just replace del v with v minus u. Here u is the final, u is the initial velocity, u is the initial velocity, and v is the final velocity. So we can write, just we replace the value of del v with v minus u in this equation. We shift t on the left sides of equation will become at v minus u. So we just shift the u to the other sides of the equation will become v is equal to u plus at. This is called first equations of motions. Hopefully you find it well and you got it. Thank you for watching.